guys, welcome to week 4 of e-learning. I hope you're enjoying your time at home and staying safe. I videoed this once before and I realized I said like 100 times, so I apologize in advance if I do that. I promise I'll make this video short so you won't have to listen to it for that long. So this week we're going to be talking about the lunar cycle or moon phases. And to start off explaining this, I think it's important for you to understand that, as you know, the Earth rotates on its axis once every day, and it also revolves around the sun once every 365 days. The moon also rotates on its axis as well as revolves around the Earth. So it takes 29 and a half days for the moon to rotate once on its axis, and it takes 29 and a half days for it to revolve around the Earth. So since those two rates are the exact same, we only see one face or one side of the moon. So if you've ever heard someone talk about like the light side and the dark side of the moon, that's what that means. So we only ever see that one side of the moon that you can see pictured on the diagram from Earth, and that's just because those rates are the exact same. So like I said, the length of rotation and revolution is 29 and a half days, and that's called the lunar cycle. So like I said, we have a light side and a dark side of the moon. So the dark side of the moon is actually a myth. So when we have a new moon, as you can see, we're not going to see a moon in the sky. It's not visible. And that's just because the other half of the moon is lit. So if you look on the diagram, you can see for every single phase, no matter what we can see from Earth, half of the moon is being lit. We just might not see that entire half of the moon. The only time that we're going to see half of the moon being lit, and that's going to be visible from Earth, is going to be during our full moon. And like I said, during the new moon, we're not going to see the lit side of the moon, and that's just because the sunlight is coming from behind the moon, and so it's lighting up the opposite side, the side that we can't see. So it appears dark to us, but it is still half lit, and so that's why the dark side of the moon is actually a myth. And like I said, moon phases describe what we can see from Earth. So if you look, for example, waxing crescent, we only see like a little sliver of the moon being lit, but if you look on the diagram, half of that moon is being lit. Each moon phase, sorry, I'm checking my notes to make sure I tell you all the important information. Each moon phase is going to last about 3 to 4 days. And that's what makes up our 29 and a half days. So every 29 and a half days, we're going to go through this whole process again, starting with new moon, going up to waxing crescent, first quarter, and then continuing on. And that will take all of the 29 and a half days. So each phase, we're going to see like waxing crescent for 3 to 4 days, first quarter for 3 to 4 days. There isn't like a specific number. It just kind of is in that range. It's in between 3 and 4 days. I'm going to use a gizmo real quick for a visualization, and then we'll be done. As I said before, each phase lasts about 3 to 4 days, and that's as we see it from Earth. The way scientists describe it is that the intermediate phases, which is everything but the 4 principal phases. The 4 principal phases are new moon, full moon, first quarter, and third quarter. And those phases are technically only 1 day. And the other phases are our intermediate phases, and those last like 6 to 7 days. Technically, that's how it works. But as we see it from Earth, we see it, each phase is about 3 to 4 days. So I want you to remember that. That's very important. So when we're looking at the time below, it might be a little bit confusing, and that's why I explained that real quick, is that the principal phases are going to be way shorter, and then our intermediate phases are going to be a bit longer, but you need to know that they last about 3 to 4 days each as we see them from Earth. So as you can see, the sun is on the right side during a new moon phase. So the back side or the dark side of the moon is actually being lit, and the side that we can see is not lit. So that's why it appears that there's no moon in the sky when we have a new moon. So as you can see, you'll start to see what I was talking about with those intermediate phases lasting about 7 days. whereas when we actually are looking from Earth, we're going to see it for about 3 to 4 days. So as you can see, we're seeing the waxing crescent. We're up to day 5 already, and we're going to see the light growing from the right in our waxing crescent. And then here at about day 7, we're going to see our first quarter. So the first quarter moon from Earth, it appears that half of the moon is being lit, and we can only see half of the moon that's being lit, and that's why it's called first quarter. Because if you divide a half by 2, it's a quarter. So that's why we call it a first quarter moon. So we're going to keep going. As you can see, that only lasted about a day, but you'll see it for about 3 to 4 days here on Earth. Here we have a waxing gibbous, and a waxing gibbous, the moon is almost completely lit, the half that we can see, but not quite. And that'll last about 3 to 4 days. And then we're going to get to our full moon. Here's our full moon on day 13. And that's when we can see the entire half of the moon that's being lit up. And we'll see that for about 3 to 4 days. And we're going to keep going, and then we're going to start seeing the light disappear from the right. So as you can see, it's disappearing from the right side. And we're going to have third quarter here in a minute. There's third quarter. So just like first quarter, it's just the opposite side. So we can only see half of the moon that's being lit. So we're seeing a quarter of it. And then we're going to keep seeing the light disappear from the right. And here we are in a waning crescent. So the light is going to keep disappearing from the right side until we get back to a new moon. Here at about 29 days. And then it starts all over again. So an important thing to remember with the moon phases is that the light starts from the right with a waxing crescent, and then the light starts disappearing from the right when we're looking at a waning gibbous after the moon, from what we can see, is fully lit. The half of the moon that we can see is fully lit during a full moon. Like I said, if you have any questions, feel free to reach out to us, and keep watching the video.
Hey there, everyone. Welcome to another Tangent with Dr. Pearson. Today, I'd like to be able to look at and investigate a little bit further about the sinister and dark side of the moon. Now, we've all heard the story of the dark side of the moon, that we only see a lit up face, and therefore it's always just dark. There's one side that never gets any light. Well, that's actually a misconception. Every part of the moon gets the equal amount of light. So let's take a look at this. A diagram that you've seen before is one where you see out here, you see all the phases of the moon, and then you also see that each time there is a moon that is half lit up. However, if you take a look, it looks like there's a backside of the moon, and this backside of the moon is always dark. But let's consider something. Here goes my light source. Now here goes my view of Earth here with the new moon, as stated here. Now basically what that's telling you, if I take this flashlight here and I go ahead and shine at the back of my head, you can see that the front of my head has no light hitting it except for the light that's already here. Same thing for the moon. Okay, so we're not seeing this face of the moon. Now remember, every time that we look at the moon, we're always seeing the same face. So just like you're looking at me right here, we see the same face of the moon. Now we go up here to the waxing crescent. So light's on the right, and basically we start seeing that light is starting to grow on the right. And then as it starts coming around, we see more and more and more light. And then as we get over here, we can see that the face of my face is lit up. Well, I don't know if you can really see it that well, but my face is lit up. So when we're over here looking at the full moon, you're still looking at my face. However, now my face is lit up. So just from that right there, we see that the face has no light to the face having full light. Just from that, we can go ahead and imply that all areas of the moon get light. So that means that this side that is lit up is totally different from the side over here, because that just flips around. So that just comes around and is now 180 degrees to the other side. That's what this angle, these angles mean here on the diagram. Okay, so basically, implication here is that there is no such thing as the dark side of the moon. Every part, just like the Earth, gets hit with sunlight at some point during its lunar day and its lunar year. Part of this reason to think about why we don't see, have a whole bunch of light during an Earth day on the moon is because an Earth day and an Earth year, or I'm sorry, moon day and moon year are actually the same amount of time. They're both around 28 days. Okay? So, no dark side of the moon. Next, talking about how the moon goes around the Earth. Have you ever wondered why everything seems to go to the left? Well, there's actually a reason for that. Just about everything in nature goes to the left. Well, so then let's think about it. When our solar system was created, it was created around our star. Our star was rotating to the left. Well, that means that everything else was going to the left. So basically, everything spins to the left. But it's not just into celestial objects. We actually see that applied all the way down to the molecules that make up life. Even our amino acids are left side oriented. Yes, we have right and left-sided amino acids, and these amino acids actually make up the proteins which help define what life is. So there's a couple prevailing theories out there as to why there's more left-sided, why life is left-sided over right-sided. And the theory that I prescribe to is because the polarizing light on our side of the galaxy actually decreases the right-sided polarity of the amino acids, giving just a slight advantage to the left side amino acids, meaning that there was more and they were able to propagate further. So we had more and more being created as compared to the right sided. And so life was able to utilize those, and that's what life went ahead and relied upon. Okay, so no dark side of the moon. We also see that everything moves to the left, and that's not just to celestial objects, that goes all the way down to the atomic level. And something that's really cool to think about is that, left side was always thought to be a weak side. And because of that, it was thought to be evil. Now, this evil side of being left-handed basically comes from the Greeks. So when the Greeks needed to go and move anything, they did everything through shipping. And when winds would come in from the left, they always knew that this went ahead and forebode bad weather. So it was evil. It was just bad to them. So anything to the left was sinister. And that's where the term sinister came from. Left-handed, meaning that we were expecting bad weather, evil weather, something bad was going to happen. And that was just carried on through time. And then as time just kept going on, it was thought that people using their left hand were actually thought to be evil. They were sinister. And that just carried on a little bit later on as we got into moving from using sinister for left to left for left. And since most people were right-handed instead of left-handed, we actually get the word lift, L-Y-F-T, which means weak, because not many people had strength in their left hand since they were mostly right-handed, being their dominant hand. Just another cool thing to think about as we move through the moon and explaining the Earth-Sun-Moon relationship and how it relates to life. Well, all right, everyone. Thank you for joining me for another tangent. I'll see you again next week.